the next part of the review just deals with some more vocabulary terms around numbers. So when we talk about numbers, we give specific words to describe what we're talking about. So for you guys right now, every single number that you know falls into our real number system. And that real number system actually has a symbol. We call it a bolded R. So it looks like this. So anytime you see something that looks like this, that is referring to the real number system. Within our real number system, we have two big groupings. One is rational numbers, and that is denoted with a bolded Q. Don't ask me why it's a Q, I have no idea. So it's going to look something like that. And then we also have irrational numbers. And there is no symbol for that one. Okay. Now, a rational number is anything that can be written as a fraction. So any number that can be written as a fraction. Okay. So for example, this would include any whole number. So if I have 2, remember we can always put that over a 1 to make it into a fraction. Same thing with a negative, so like -3, I can put that over 1 to make it a fraction. Fractions themselves, so like 1/4 would be a rational number, or -2/5 is a rational number. Any decimal that ends, so for example 0.25, since that decimal point ended, I can rewrite it as a fraction, and this particular fraction would be the 1/4. Or any decimal that repeats. So if I have 0.3 repeating, that would be the same as 1/3. So I can still write that as a fraction. Okay? And this includes really big numbers as well. So any number that can be written as a fraction, which includes decimals that end or repeat, is going to be considered a rational number. And then irrational numbers are decimals that don't end or repeat, is usually how we can identify those. So decimals that don't end or repeat. So our most common example for this is going to be pi. The other one is e. Square root, so like the square root of 2, for example, that has a non-repeating decimal. We could have the negative on the outside, so like negative square root of 11. Now, if we have a perfect square root, so for example, the square root of 9, that would be considered a rational number since it can be simplified to 3. So if we can simplify to a rational number, then that would be considered a rational number. Okay. Now, irrationals, we don't break down any further. Within our rational family, we have the integers. So that's our next subgroup. And this is a bolded Z. Again, don't ask me why it's that letter. I have no idea. Now, integers are going to be positive, negative whole numbers. So I'm going to abbreviate. So positive, negative whole numbers, including 0. Now, I'm saying including 0 because 0 is not considered positive or negative. So that's why we have to have that extra statement in there. So again, our examples for this would be like -2, -1, 0, 1, 2. And I can keep counting in really either direction if I want. Okay. Now, every integer is considered a rational number and considered a real number. Okay. Now, within our integers, we have another subgroup called whole numbers. So again, this is a bolded W. Now, these are going to be just the positive whole numbers, including 0. So again, we would start at 0, and then we would count up. So 1, 2, 3, and so on. Okay. Now, every whole number is considered an integer, which is considered rational, which is considered real. And then our last subgroup are the natural numbers. And this is a bolded N. Okay. Now, for these, we want to think of them as the counting numbers. So this does not include 0. So 1, 2, 3, 4, so on. Now, again, this is more important for you to know if, let's say, in our homework problem, it's asking for a rational number or an irrational number. And then the other important one is going to be knowing what an integer is. So integer is referring to a positive, negative whole number or 0. So if our answer has to be given as an integer, it means that we can't be dealing with fractions. So that's why it would be important to know that. Now, for right now, we're not going to deal a whole lot with that, but later in the year, we're going to add numbers to this grouping. So I just kind of wanted to put it out there as a review in case you don't remember what those things mean. Now, again, as we classify numbers, so if I'm at -3, I know it's a real number. It's also a rational because it can be written as a fraction. And then it fits into my integer group because it's a negative whole number. But it's not a whole number since it is negative. Okay. And then if you are asked to classify, make sure that we simplify. So square root of 49 is really the same thing as 7. Okay, so again, 7 is going to be real. I can write it as a fraction, so it is rational. It's a positive whole number, so it's going to be an integer. And since it is positive, I would count that as a whole number. And it fits into our natural numbers as well. So the only difference between our whole number category and our natural number category is 0. So 0 is included in our whole numbers, but it is not included in the natural counting numbers. All right, 2/3, that cannot be simplified, so that is going to be real. And then it's a fraction, so that's rational. And it's not an integer because it's not a whole number. Okay. 0 is a real number. It can be written as a fraction, so rational. Fits into our definition of integer. And a whole number, but because it's 0, it's not a counting number. Because when we count, we always start counting at 1. Okay. All right, and again, I'm going to need to simplify this. So 15 divided by 5 is really the same thing as 3. So I'm really classifying that 3 number. So it's going to be real, rational, integer, whole, and natural. And just to kind of add something else, so problem 6 here. Let's say I had the square root of 3. Okay, well, that's a real number. I can't write it as a fraction, so this would be an example of an irrational number. And then irrational doesn't have any subcategories, so if we're picking irrational, at that point we are done listing our numbers.